Good evening and welcome everybody, this is Obi-Wan Pez and Simplex Pachinko. We are doing some math tonight. If anybody has anything they want to talk about, feel free to let me know. And if everybody is, I don't know, not here, going to be bored or what have you, then we might move on to do a bit of gaming tonight in order to, I don't know, stay awake, something like that. Nah, it'll be fine. I did want to do one quick thing, and that was Dawn had inspired me to do some differential equations tonight. Specifically, I want to look at one particular kind of thing. I'm going to use an example that we had last night, I think. That's good enough. So we have y double prime plus 4y prime plus 4y is equal to, so we know already that the characteristic of the null space is going to be r squared plus 4r plus 4 is equal to 0, assuming that, and we had actually done it not with r's but with lambdas when we talked about it last night, because these are our eigenvalues. So our null space solution is that y is going to be equal to c1 e to the negative 2t plus c2t e to the negative 2t. And I wanted to know what was going to happen if we get a t squared e to the negative 2t. For the inhomogeneous portion. So one of two things is going to happen, and I'm not exactly sure which because it's been a really long time since I've done this, but okay, so hypothesis 1, y particular is going to need to be some form of a t squared e to the negative 2t. I think that's too easy, because what's going to happen is you end up with a bt e to the negative 2t and a c e to the negative 2t, which then get absorbed into null space. I think that causes this entire hypothesis not to work at all. Hypothesis 2 is that we're going to start with yp is equal to a t squared e to the negative 2t plus bt, and yes, I know it looks almost exactly the same as what I just wrote. Fear not, this is going to change. A squared e t a squared t squared e to the negative 2t plus bt e to the negative 2t plus c e to the negative 2t, and then we say that we need to multiply this whole thing by t squared in order to get our lowest term to not be in the null space. Now I'm pretty sure that that's correct. But I could be wrong. So if we do this, we're going to say yp prime is going to be equal to, and here's where it gets a little wonky. We're going to keep okay, so like if null space had no e to the negative 2t term, then y sub p would end up looking like at squared e to the negative 2t plus bt e to the negative 2t plus c e to the negative 2t. Right, so like that would be it if the null space had no e to the negative 2t term at all. So again, hypothesis 1 is don't change it, but at the end, when we get to the final bits, it's going to just end up clearing out because we already have B and C. The more I talk about this, the less I want to actually do it. So I think that this is correct, that hypothesis 1 will fail. All right, 2 at e to the negative 2t minus 2 at squared negative 2t plus b e negative 2t minus 2 bt e to the negative 2t minus 2c e to the negative 2t. Alright, some of these should combine. So we've only got one squared term, negative 2at squared e to the negative 2t. And in fact, right, let's factor out e to the negative 2t from everything and then just leave it by itself at the end. All right, plus we've got a 2a minus 2b t e to the negative 2t. And then we've got a plus b minus 2c as a constant times e to the negative 2t. Alright, so y particular double prime is going to be, take the derivative of the first part, which is going to be all that stuff, negative 4at plus 2a minus 2b. Okay, and then the next one's a constant, so that goes away. All that times e to the negative 2t. Minus 2 of the polynomial we had earlier. Negative 2 at squared plus parentheses 2a minus 2b t plus b minus 2c e to the negative 2t. So that's going to be e to the negative 2t times the quantity. Still only one squared term, so that's a negative 4. Nope, that's a positive 4. At squared. In the linear term, we're going to have a plus negative 4a plus 4b minus 4a from the first term t plus 2a minus 2b minus 2b plus 4c. E to the negative 2t times the quantity, 4at squared. Plus parentheses negative 8a plus 4b t plus 2a minus 4b plus 4c. Yep. I'm betting this isn't going to work because we have 1 t squared e to the negative 2t, and then we've got 0 for all the rest, but it doesn't have to actually be 0. So our linear and our constant terms can add up into the other one no matter what their values are, and it ends up getting us something that, right, is part of the null space solution. So literally anything that we have is going to work just fine. So that's not really cool. On the other hand, if we do the acceleration thing and say, okay, we're going to accelerate exactly what we had for y sub p, but then multiply it by t squared, gonna have to do that one over. All right. My particular prime is going to be multiply through by t squared. We end up getting a t to the fourth. So 4a t to the third. And again, factor out e to the negative 2t to the very, very end of all this, because we don't need to stress ourselves out by having individual power rules on every single term. Let's just factor it out, do one power rule over everything. Okay, plus this was bt, so now it's going to be 3t squared. B. Okay, let's flip that around. 3b t squared. Yep. Plus 2c t e to the negative 2t on all of it, plus a negative 2 minus 2 times a t to the fourth plus b t cubed plus c t squared e to the negative 2t. So that's going to be e to the negative 2t times the following. We've got a negative 2 a t to the fourth plus parentheses 4a minus 2b t cubed plus 3b minus 2c t squared. Yeah. Alright, so y sub b prime. So y sub b double prime is going to be equal to negative 2 e to the negative 2t times all that same stuff again, 2a t to the fourth plus 4a minus 2b t cubed plus 3b minus 2c t squared. Okay. Plus e to the negative 2t times derivative of that polynomial, which again, polynomials are pretty nice at least. Negative 8 t cubed plus parentheses 12a minus 6b t squared plus 6b minus 4c times t. Wait. Yeah, I did miss one. Maybe? Yeah, I missed one. Plus 2ct. I knew I was missing something, because here we should have a higher, lower degree. When we took two derivatives of something that has t squared in it, it should have a constant somewhere. Plus 2ct. Okay. Take the derivative of what's there. We should then only have a plus. Hang on. Right. All in one line. That's a 2ct. Okay. Good. 2c. Just as a constant. This actually does look a lot better because now we're getting something that has a constant term in it at the end. So when we've taken two derivatives, now we get something that has a constant term times e to the negative 2t. So y double prime plus 4y prime plus 4y. Y is equal to t squared e to the negative 2t. Then this means that we should have that big thing. Alright, e to the negative 2t is going to clear out of every single term, and we don't have to worry about it anymore. So, this means that we're still going to have I should have rewritten this one more time. This is a positive e to the negative 2t times the quantity. This is a positive 4a t to the fourth. Minus, just plus, times a negative 8a plus 4b t to the third plus a negative 6b plus 4c t squared We've got another term up here too. We need to move back. Right, so our cubic term has these, but it also has that one. So that's going to be also a minus 8. That's not right. It's an A. Negative 8A. Oy. negative 16a overall. And same deal with the squared term. We need squared term up top as a negative 6 plus 4, negative 6b plus 4c. Then from the bottom term, the t squared term is going to be a 12a and a negative 6b. So we're going to get 2 negative 12b and a positive 12a. Right, because we had a negative 6 from this one, negative 6b, and another negative 6b from here. Okay. This is going to be a negative 2 times our 2ct, so negative 4c with a negative 4c below is going to be negative 8c and a 6b. T. And a plus 2c at the end. Cool. Whew. Hey, Megalomorph. Hey, Les. How's it going? Why does it have numbers? I mean, very good question. Should be all letters at this point. So we had originally started with the assumption that y sub p is going to be a times t squared e to the negative 2t plus bt e to the negative 2t plus c e to the negative 2t. And then we said that all of this stuff needs to be accelerated out so that we don't have any terms that are going to be part of the homogeneous solution, the null space solution, which is going to be c1 e to the negative 2t plus c2t e to the negative 2t. So the first term that we are allowed to have in our particular solution is going to be c, capital C, t squared e to the negative 2t here. Then when we take the first derivative, we get this monster down here, and second derivative, we get this monster down here. Then we need to plug all that back into our original differential equation with the non-homogeneous portion, and that should allow us to solve for A, B, and C in those particular places. No, not that one. Differential equations dis. You're like the Bernoulli or differential equation. Ordinary. Ouch. Perhaps even two-dimensional. Okay, so I said we can clear out all of our e to the negative 2t's from every single portion of this all the way up. That's going to be fine. So we still have kind of a big thing to deal with. This is 4 at to the fourth plus parentheses negative 16a plus 4b t cubed plus 12a minus 12b plus 4c t squared plus 6b minus 8c times t plus 2c plus 4 times y prime. That's going to be this line here. So 4 times that is going to get us a negative 8 at to the 4th plus 16a. Ooh. Might still work. 4 times. Right, okay. 8b t cubed plus a 12b. Some of the stuff canceling out is nice, right? That's supposed to happen. Minus 8c t squared plus 8 ct. Okay. So that gets rid of some stuff automatically. At cubed here. Our bt squared term here. Partial cancellations and other, you know, just plain addition stuff elsewhere. So that's okay. And then 8 ct here and here. Okay. Then 4 of the original solution, 4 of these with the t squared in its appropriate locations. So 4 at to the 4th. Okay, yep. Stuff drops out. That's okay. Okay. 4 bt to the 3rd. Plus 4, yeah, okay. 4c t squared. Then that summation, once we actually get rid of, right, all of those together, all of those together, and all of those together are gone. We still have stuff left over. Haha. So we have a 6b times t, and we have a 2c. Oh, and a 12a. T squared. Alright, so 12a t squared plus 6b t plus 2c is going to be equal to what's on the right-hand side of our differential equation, t squared e to the negative 2t. So just t squared at this point. That feels too easy. Well, let's try it. So this means that 12a is going to be equal to 1. So a is going to be 1/12. So the solution here is that y sub p is going to be 1/12 t to the 4th e to the negative 2t. And b and c are both going to be 0. certainly is the implication. Hum. So let's also go to, let's go to Wolfram and see what it decides. Solve y double prime plus 4y prime plus 4y is equal to t squared times e to the negative 2t. That's it. Nice. That's it right there. So yeah, c2 e to the negative 2t times t, c1 plus c1, e to the negative 2t is the homogeneous or the null space solution, and then we've got a plus 1/12 t to the fourth e to the negative 2t. Awesome. So that is the correct method to go through it, and that will work for us. Again, the issue that we had with hypothesis 1 here was that we were taking the polynomial a/t squared e to the negative 2t plus bt e to the negative 2t plus c e to the negative 2t, and then saying, like, if this is going to be part of our solution, then these two bottom terms here are going to be part of the null space solution. So, like, in the end, they don't end up being used, but they are, in fact, going to be used. It's just that we have to first accelerate them, get them away from the null space, and say our lowest term here, c e to the negative 2t, needs to now become c t squared e to the negative 2t in order to raise it away from the same polynomial degree of our null space solution. So c2t e to the negative 2t needs to end up becoming, no, we need c t squared e to the negative 2t as our first possible part of the solution. Which then, because we did that, that raised a t squared e to the negative 2t up to a t to the fourth e to the negative 2t. And again, that was where our solution came from. We ended up with 1/12 t to the fourth e to the negative 2t. If we hadn't done that, right, if we had just tried to jump in like from here, again, I'm not exactly sure what would happen, but we would never get a t to the fourth. All right. What else does anyone feel like talking about tonight? Because that was kind of my thing for differential equations. Somebody brought up Fourier series earlier, and I was like, ooh. But I don't know. It's been a really long time, like 20 years, since I've done any of this. So